Roger Mudfossil University, as always, digging deeper. You discover things you never suspected you would discover. Now, what am I referring to? Well, I've been looking into the magnetosphere and our interaction with it and the new phenomena that are showing up, which are magnetic anomalies. And I say they are due to impacting into a different region in space. So I go back looking, and I'm seeing, well, what can I find out? I go back, I end up going back to 2009. Well, it ends up in 2007, they discovered, they have 5 of these spacecraft, and they discovered a very interesting thing that it says they discovered a breach in Earth's magnetic field, an opening in the field 10 times larger than anything previously thought to exist. Solar wind can flow through that opening to load up. Solar wind is magnetic particles to load up the magnetosphere, which is this surrounding envelope of electrons, really, for powerful geomagnetic storms, first of all, and then all these different flashes and breaches and sprites and anomalies they're seeing. But the breach itself is not the biggest surprise. Researchers are even more amazed it's a strange and unexpected way it formed, overturning long-held ideas of space physics. And they should be overturned because they're just not right. Okay, my friends, these are sprites. And you say, well, Roger, what is a sprite? Well, a sprite is something that is an overload of the atmosphere. And I can make this in absolute certainty. And I can tell you how these are created and where they come from. And they, and whenever I say they, I mean the experts and the scholars, the intellectuals, the teachers, the professors. They, I don't think, have any clue. From what I can see, they think they start up here. They do not. They start right here. And they come up from here, they smash into the ionosphere, or the lowest level of electronic saturation. Right out here is saturated electrons coming from space, because we are being flooded with these at this point. Way more than normal. This decides we have too much electricity out of here. We got to get out. So they shoot up here and smash into this, call it whatever you want. I call it the ionosphere. Some people, oh, that must be the firmament. Call it, I don't care what you call it. It's a layer of electron density. This is electron density shooting up, and you can see violent interaction. And then what happens? This area glows so much, it says, we got so many electrons here, you got to get the hell out of here. Well, they should go up, and a lot will, but the rest will shoot back down, trickle back down to Earth in these little fluty looking things that are coming towards the Earth. The main impact is upwards, and anybody that has eyes to see could see that. I mean, but they say, oh, look at it happened up here, and then all of a sudden they come down this way. No, absolutely not. And I'm going to show you another interaction that happens from the Earth, which is overcharged with electricity, and in addition, the sinkholes are collapsing. And the fabric of the Earth, there's a fabric on the Earth that covers multiple areas which are karst, limestone. They are literally biology that are holes that will go way down into the Earth if the fluids in them go down. And then you have a fabric over that hole, and when that hole collapses and that fabric plug goes down, it will crush the electronic particles and elements that are gases that have collected in that tube. It will crush them into electronic emission. They will shoot up, and you will see exactly what they do now. This is what they do. And you always see it when there is atmospheric disruptions. You see this over here, how dark and cloudy it is, over here, how dark and cloudy. I have dozens of pictures like this. It's always when the fabric of the earth is being disrupted. This one is so obvious because it's a water spout. When that happened, it just dislodged that plug, whoop, it fell down and shot that beam up. When it compressed those atomic gases, it does the exact same thing as a laser do. And because it's a tube, pew, shoots up like that. Same thing happened here. Same atmospheric disruption, which causes the fabric of the earth to get floppy. And this is down in Florida, which is littered with sinkholes. Now this is Civitavecchia, Italy. Now I don't know where, but I can tell you one thing, that's what happened there. That's a crusher of a sinkhole creating atomic shock. Shock studied it, and that creates atomic emissions of the orbitals, primarily in methane gases and so forth, which are the decomposition gases that occur in these gigantic tubes like this one. All right, this is down in Guatemala. Now, nobody drilled that hole. That's a collapsing sinkhole. And what was down here was bazillions and zillions of molecules of atomic gases. And atomic gases are hydrogens, methanes, and that kind of stuff. Now, when that plug drops, now this one maybe just fell in slowly, I don't know. But if they drop in a catastrophic compressive drop, the whole thing lets go at once. Like you shake this and the plug drops. Then you get that electronic emission. And they shoot those light beams directly through the plug and everything because they're extremely energetic. And they will just shoot right into space. And that's what we see. And the Steves are another thing that they have no clue about. They have just started seeing those, which are, well, let's see if I can find something about them. Okay, this is from space.com. This is another problem. This weird aura-like phenomena called Steve finally has an explanation. No, it doesn't. They don't have it right at all. This is an emanation from Earth in the lower zones instead of up at the poles, which they usually have the aurora borealis and the aurora australis, the northern lights, southern lights. Well, these are lower, and these are the lines of flux. And then it's shooting out into space because it's trying to get rid of electricity. Normally it comes into us and it displays. This is going out. All right. Steve's, formerly known as strong thermal emission, which it means to emit from here, velocity enhancement, is different than auroras. In the northern hemisphere, the phenomenon is visible from areas farther south than a typical aurora. They say much farther south. And Steves have a picket fence appearance. And the reason is because instead of up at the poles where everything's converging together and they have like these little ripples that show, these are going out through further areas where there are more magnetic lines of flux divergence. Up here, they're all together. Where they're going out, they're like this. That's why they see those bands. Okay, and they're showing that these mauve streaks occur when charged particles are heated up high in the atmosphere further south than typical auroras. This occurs outside the auroral zone, so it's indeed unique. These are those Steves. Okay, this is a couple of years ago, physics.org, Revolution in Understanding the Ionosphere, Earth's Interface to Space. And these are the different colors in the air, which means the different frequencies that can penetrate and do certain things, and the different molecules that interact with the light that hits them. Like nitrogen, you get a lot of blue. Now, what we have out here is the spinning particles interacting with the particles smashing into it, causing some extreme activities out there. Lesser as it comes down. Now, the spinning particles in space create our magnetic field because they're spinning against the particles that are impacting. Now, I showed the push of the barometric pressure that happens twice a day, And it happens, they've known about it forever. So it's not a big thing. We're pushing against something. We're just not floating in space like there's nothing out there. We're pushing through it. They show it every single time they show something. They know it pushes solar sails. They know it creates our magnetic field. They just don't get the relationships and the magnetic fields in the Earth and how the Earth is being flooded with too many electrons. It's got to get rid of them. They shoot in the atmosphere. That's where you get these Steves. And these lightning, well, not lightning, they're actually shots of electrons going into space. We've got to get rid of them. There's too many here. That is the heat. That's heat. And that's not, I don't think, caused by a carbon dioxide. It's caused by rubbing through something serious in space that we have not encountered before. And the ancients kept a very close eye on the sky. I find it very interesting that they're gone. All of a sudden they left all these beautiful pyramids and all these things. And I don't know why. I don't know where they went. Not here now. But they certainly were looking at the skies. They understood very well the place we are in our region in space. In my estimation, from everything I've looked at, they know more about it than we do. And they know more about alchemy. And they know more about history. I think they knew more about every single thing than what is being taught. And medicine, everything. So, that's my estimation of where we are now in science.